Hi there, and welcome to Math with ACE. We are talking about statistics today, and we're going to focus on standard deviation. Standard deviation is a measure of variation in a data set, and it tells you how spread out your data is. Is your data very close together? Is it very far apart? Standard deviation is the most commonly used measure of spread or variation. When you're talking about percentiles, you're talking about standardized scores like the ACT or the SAT. Those are all reliant on standard deviation. What happens is we determine how far away on average a value is from the average. And so what we have to do is we need to do some calculations to determine what is the average, how far away each value deviates, and then we need to divide that by the total size of our sample to get our standard deviation. Now, there's some square roots and squaring in there because all of the values need to be positive. If you were to find the value deviations and add them all together, deviations from the average will sum to 0. And the reason is because the mean balances the distances. So what happens is you have all of these values and you have the average, and the average is like this balancing point. And so the distances on either side will be equal. That's the whole point of an average. So if you were to determine how far away each value is on one side versus the other, and you add all those distances up, well, some are negative and some are positive. So those positives and those negatives will sum together to be 0. If your deviations don't sum to 0, then something is wrong. So in order to counteract that, we need to square the deviations to make them positive. And then we'll divide that by our sample size. And this calculates our variance, which is the squared distance average of the means. The following data shows different types of pet food stores in the area carry. So there's 6 different types all the way up to 12 different types. What I'm going to do is I'm going to copy that data, Control C, and I'm going to paste the data, Control V. Now it's all in one cell. And if you've watched the video that I created on how to adjust this, I'm going to go ahead and I'm going to turn this data text into a column. So I'm going to go to the data menu, and I'm going to hit the 3 options for more options, and I'm going to select split text to columns. And the semicolon is going to split my data. So I'm going to apply that. But I now want it to be in a column, a single column rather than in a single row, because that works better for me visually to see it all in one area. So I'm going to copy that, and then in the next cell down, I'm going to paste it as a transpose. So paste special, and then I'm going to transpose the rows. And then lastly, I just need to get rid of that first row. So I'm going to delete row 1. And so now my data is all set to go in that first column. So what I could do if I wanted to calculate the standard deviation is just say equal STDEV.S, select the data, and I'm finished. So let's do that. Let's go over into column J, and I'm going to select equal STDEV.S for sample, open parenthesis, and now I'm going to select the data. So my data was in column A from 1 all the way down to 29, and then I need to close my parenthesis. So my sample standard deviation is 2.153014. I am going to decrease the number of decimals so that I have 3 decimals behind, or 3 numbers behind the decimal place. So that is the standard deviation. So essentially, the data is about 2 away from the mean. Well, without kind of doing any calculations, it's kind of hard to understand, well, what does this 2 represent? So let's create a histogram. So I'm going to select my data, and I'm going to insert a chart. And it's a statistical chart. So I'm going to select a histogram. And now here's my chart. I think I want a few more bin widths. So I'm going to adjust. Let's format. So I'm going to right click here, and I'm going to format. And I'm going to change the number of bins by selecting series. And I think I want to do 5. Let's say 5. And see what happens. Okay, interesting. So it looks like there's a bunch of values in the first, and then it gets more increasing as I go. So let's see if I can have my underflow bin, my overflow bin. My values go from 6 to 12. I could also have a bin width of, let's say, 1 and see what happens. Now I get a few more. So there's a lot that only have 6 options, and then it gets more as I increase. Okay, so how far away do they average? From the average, well, the data goes from 6 to 12. Let's calculate the average. I'm going to select equals average, open parenthesis, and then I'm going to select the data from A1 to A29, and then I'm going to close parenthesis, and my average is 9.276. So if I look at my chart down here, 9.276 is going to be in this bin right here. So my average is right in there. And then my standard deviation tells me that the values are on average about 2 away from that 9. So between 7 and 11. Let's calculate the standard deviation using the process. So the first thing that I want to do is I'm actually going to insert a row here. And this is the value. Now the standard deviation determines how far each value is from the mean. So what I need to do is I need to calculate the deviation. And I do that by taking the value minus the average. So 6 is 3 and some change below the average of 9. I can then copy that formula all the way down. So I'm going to hover over the cell, but I do want to make sure that this column, this cell doesn't change. So I'm going to put a $sign in between so that it stays J4. But all of the others, A2 is going to now become A3, A4, and all the way down. So I'm just going to scroll. I'm going to hold that down until the very bottom and release. So these are all of the deviations. So it starts out 6 is the furthest away. And then as I get to 7, it's 2 and some change below. 8 is 1 and some change. 9 is just a little bit below. 10 is above. 11 is above. And 12 is above. So all of the values below 9 are negative, and all of the values above 9 are positive. Let's test our theory that the sum would be 0. So let's say equals sum B2 to B30. Our deviations sum to 0. That's what we needed because the average is supposed to balance the distances. Well, that doesn't help us in any calculations. And so what we need to do now is we need to square those values. Okay. So now we're going to square the deviations. So in our next column, we're going to do a square where we take an equal sign. We go to B2, and we could do square. I'm sure there's a function for that. What I'm going to do is I'm going to do a multiplication symbol and then just go back to B2. So it's the same number twice, which is what a square is. And then again, I am going to just hold down the corner and paste that formula down for all of these. Now, if I was to sum this, selecting all of the data that we worked with, notice that the sum is no longer 0 because the square, a negative times a negative is a positive, and a positive times a positive is a positive. And so all of these values are now positive. So I have summed all of the deviations, and now what I need to do is I need to divide that by n minus 1 because this is a sample. So I'm going to take the sum of the squared deviations divided by the sample size minus 1. Okay, so in order to do that, I've already summed the squared deviations. I'm going to need to divide that value by however many we have minus 1. So you can do a few things. You can use a formula where you count how many values you have, or you can just highlight your data. And in the bottom, it tells me I have 29. So the count is 29. So 29 minus 1 is 28. So what I'm going to do is I'm going to take the sum here. I'm then going to use the division symbol. And I can do 29 minus 1, or I could have just written 28. So that is the variance, because I'm talking about the square deviation. So now I need to go back and square root this to get the standard deviation. So what I'm going to do is I'm going to press equal, and I'm going to type SQRT for square root. Open parenthesis, selecting the value of our variance, close parenthesis, and hitting enter. Look at that number. That number matches what the formula of the standard deviation of the sample gave us. So here's what we did. We calculated the standard deviation going step by step, but we also used the formula. So hopefully you get an idea of what this 2 is representing. We calculated the average. We determined how far each value was from the average. We squared that to make it positive. Then we divided that by our sample size minus 1 and then square rooted it so that we could get our sample size, the standard deviation of our sample. So essentially, looking at our chart, knowing that the average was in here, 9, most of the values, or the average deviation from the average of 9 was about 2. Hopefully you found this as fascinating as I did, and it was helpful. Thanks for watching.